Yeah. Okay, welcome everyone. Welcome to Fridays for Future. I'm going to tell you something about the biggest mass extinction to ever have happened on Earth. And first I'll give you a little how to kill all life guide on Earth, okay? So to do that, we need things like greenhouse gases, increasing temperatures, heavy metals, pollutants, ocean acidification, sea level changes, burning of coals, and ozone layers breaking down. So these are all the sorts of things that combine to create mass extinctions from our study of these events in the past. And unfortunately, I'm not going to speak right now about the current mass extinction, but tell you about something that happened 251.9 million years ago. And all of the factors that I've just listed combined to create the biggest mass extinction that the Earth has ever seen. So, what firstly is a mass extinction? How do we define this? Well, species go extinct and they evolve all the time, okay? That's not something unusual if you look at the geological past. And this is called the background rate of extinction, or the normal level of extinction. Oops. Little malfunction there. There we go. So this is the background rate of extinction. And that's normally in response to different environmental changes, otherwise known as natural selection. Species will evolve through responses to change, and mass extinctions happen when these changes are too rapid. Sorry, this is not working. Maybe I should take these off. Okay. So mass extinctions happen when these changes are too large or too rapid for many species to adapt fast enough. And so instead of being able to change or evolve, they go extinct, and they don't contribute any further to the tree of life. And remember that extinction is almost certainly forever. So we have these great movies like Jurassic Park, where people, bring dinosaurs back to life, but that's not an option for us right now, and probably won't be for hundreds or thousands of years if we ever achieve it. So we're not going to bring back the species that are being driven extinct by our current climate crisis. So there have been 5 big mass extinctions in the history of our planet, or at least in the last 541 million years. And probably most of you know more about the end Cretaceous extinction that killed the dinosaurs. So this was an asteroid. It was something that came from space, and it was not within human control. But I'm going to talk about the Permo-Triassic extinction, which was a much, much bigger mass extinction than the extinction that killed the dinosaurs. So if we look at some statistics, the Permo-Triassic mass extinction wiped out about 3/4 of all land vertebrates and about 81% of species that live in the oceans. So it literally almost killed off life on the planet. And how do we know about these mass extinctions? Well, I'm a paleoecologist. I study past ecosystems and how they change through time. And paleoecology or paleontology is the branch of geology that studies the fossil record and looks at the past life that has lived here on Earth. And if we look at how life has evolved and changed through time, we see that there's certain periods in the geological past where many animals all at once, or plants and invertebrates, don't continue. And we know that these represent mass extinction horizons where terrible events took place that affected biodiversity levels. And so from this fossil record, we can tell that at the Permo-Triassic mass extinction, it was the most serious, but how do we know what caused it? Well, you had a large area in northern Eurasia called the Siberian Traps, and 251.9 million years ago, this volcano erupted and caused a massive release of greenhouse gases into the atmosphere, and also nasty things like CFCs, what destroyed the ozone layer some decades ago. And so this was the main driver of these extinctions, was this huge release of volcanic lavas into the atmosphere. But there were a number of other effects that also then worked together to create this mass extinction. A large one could have been pollutants by heavy metals, which were also released by the volcanoes. And then the destruction of the ozone layer was very important. So from my study of fossil pollen, I have been working with colleagues to find out that the signals of this ozone layer breakdown are recorded in these fossil pollen grains. And when we looked at the pollen that came from trees after the Chernobyl radiation disaster in 1986, the pollen that was found 251.9 million years ago, and this pollen from the Chernobyl disaster looked exactly the same. It had completely mutated, and it wasn't viable anymore. It wouldn't have been able to fertilize new plants. And so from this, we know that there was widespread radiation during the Permo-Triassic extinction, and that caused breakdown of the ozone layers, mutations, all sorts of terrible cancers and those things. So initially, these huge volumes of greenhouse gases that were released into the atmosphere by the Permo-Triassic extinction, they created an initial warming of perhaps 5 to 6 degrees average globally. But then what happened is a runaway greenhouse effect took over. So perhaps we had things like frozen methane hydrates in the deep oceans. And because there had been enough warming, this then melted these frozen hydrates, which in turn released many more greenhouse gases. And so in total, the temperature on Earth rose by about 15 degrees perhaps on average. And so of course this was a killer. All the life in the seas died. It was like an oven, terribly acidic. So all these factors combined together to create this mass extinction. If you look at the recovery of how long it took for life to recover, you only see true corals forming and true forests about 20 to 25 million years after the Permo-Triassic extinction. So if we put that into perspective of a human life, that's about 200,000 generations of humankind if we had to have an extinction of that magnitude happen on Earth today. And so we do know that animals' life before and after the extinctions was completely different. And so we need to remember that for the extinctions that are happening today. So it's very important to study the geological past, and it's relevant for today for many reasons. First of all, because we can understand the multiple factors that came together to create these sorts of mass extinctions in the past and examine if we are indeed creating them again in the future. Also, climate models tend to underestimate climate change if you compare that to hard geological evidence that you find in the record. So we need more science to keep refining our climate models and finding out how the Earth actually could have reacted to these tipping points. And we also know that Earth responds slowly to some changes like permafrost melting, deep ocean warming, and vegetation restructuring. The changes that we have seen up until this point are not reflective of the changes that we can expect on a longer term as humans are altering the atmosphere. And so by studying the past 5 mass extinctions, we can talk about whether we are truly entering a 6th mass extinction now. So a lot of people talk about that, but in order to know whether we are truly entering the 6th mass extinction, we have to know, does it exceed the background level? That's really all we need to ask. And so 2 factors determine the background level of extinctions that are happening: the rate and the magnitude. So firstly, the speed at which creatures are going extinct, and how fast are they going extinct compared to previous extinctions. So if we look at the rate of current extinctions that are happening on Earth today, we find that this rate is much more similar to previous extinctions in our past than to the normal rate that you see in between extinctions when the environment isn't changing very much. We also know that we are losing just vertebrates at least 100 to 1,000 times the background level today compared to before we entered this era of human modification. And so yes, in terms of both the rate and magnitude, science is telling us that we truly are entering the 6th mass extinction, and that if we don't take steps to stop it, it's going to continue. So what can we do? Well, we need more science, but we can't wait to act, because if we wait, it will be too late. So for already our knowledge of the Perma-Triassic extinction holds some important lessons and warnings for us in the sixth mass extinction today. What it tells us is that the climate and the ecological crisis are linked, and that if we only stop warming, that won't solve the problem alone. Because if you look at the factors of what created the Perma-Triassic mass extinction, yes, you had a runaway greenhouse effect, but all these other things like heavy metals, pollutants, ocean acidifications, burning of coals was a huge thing. So when lavas were released from the volcanoes, they ignited huge reservoirs of coal that were under the earth, much older coals. And so, in an essence, the Perma-Triassic extinction is maybe the best analog that we have for what humans are doing to the planet today. And by losing so much life, about 3/4 of life on Earth, perhaps that's what we can expect. So it really tells us we need to act now. And yeah, I'll leave it to you to ponder whether we truly are recreating a Perma-Triassic mass extinction in our lifetime. Thank you. I hope you have questions about extinctions. So you're saying, what can we, the world, do? As an individual do? Okay. So the most important thing is first to know how serious this is, and I think that you all do because you're here. Something that's very important is to vote for political parties who take this seriously and understand that this truly is a climate emergency and that we have climate breakdown. But as an individual, it's easy to look at your own lifestyle and also make really positive changes and do what you can. So things like not flying as much, not eating as much red meat. That's a huge contributor to greenhouse gases. Making sure that your homes are well insulated so that we're not wasting more energy than we need to, turning off lights, not using more water, all those sorts of things. And then telling people about it, that's really important. So once we're all on board, we can create a mass movement that will force governments to help. Because as an individual, only about 40, even if every individual had to be completely carbon neutral, that would only result in maybe 40% of carbon emissions being cut. So governments and businesses and corporations are really at least 60% or more. And so government has to get on board with us to do this. Sorry, shouldn't do that. Thanks.
Hello, my English is not, I don't understand every word you say, but for me it's not carbohydrate, no?
Carbohydrates?
The CO2.
CO2, yeah, carbon, yeah, carbon.
I don't think that's the main problem.
Tell me why.
Because the main problem is that we are too many people. We're rising now from 7.7 to 8 billion, and to 2050 they talk about 10 billion. So that's the main problem, as I see it.
So ecologically, that is a very serious problem because the Earth is currently carrying perhaps 3 times more people than what it can sustain.
Yeah.
But that's the ecological crisis. Whereas for the climate crisis, the irony is that it's the richest 10% of the world who are creating most of the climate emissions. Yeah. So actually the poorest people are creating really low carbon footprints.
Okay. I'm working with a very bright man. He's called Per Almgren. He's 76. And we're writing now a 12 points, how do you say it? 12 points action plan. What to have to be done.
That's great.
And we will have a globe meeting in the globe, the Globen, the 19th of October, and we will present that 12 points plan then. And I want to have contact with different science that can help us, me and my friend, and the accommodation I'm creating now.
So you could definitely get in touch. Definitely.